a mushroom cloud exploded into the sky with the force of 20,000 tons of TNT. A week after the explosion, Benjamin was allowed into Ground Zero. What he saw was startling.
And of course the whole tower that the device was on, all that steel, tons and tons of steel, was absolutely vaporized.
And a bigger surprise was what had happened to the ground.
Oh, it was covered with green glass, the melted sand here. All the sand had melted on the top, the first quarter inch or so. This green glass was covering the whole entire area, and it was cracked, and but one could walk on it, and you'd crunch. It'd be walking like on a field of maybe ice.
The sand was transformed into a thin layer of glass, covering an area nearly 600 meters across. Could something similar have happened in the Egyptian desert, but on an even bigger scale? The area where the desert glass is found is huge.
From here we go down another about 10 or 15 kilometers and we find still some glass, and we go up about another 30 kilometers even and we find glass. And we're very close to the center of the area where we have the glass around here.
If such a large area of glass was formed as a result of an explosion, it must have had the power of many thousands of atomic blasts. A natural explosion of that magnitude was completely unheard of. No one had any idea of how such a devastating blast could have been produced. The only clue came from a place called Tunguska in the forests of Siberia. In 1927, a Russian scientific expedition visited Tunguska to investigate a massive explosion. The explosion had actually occurred in 1908, but Tunguska is so remote it was nearly 20 years before they saw the scale of the devastation. They were astounded. More than 80 million trees had been destroyed. The scientists were puzzled. What could have caused such an enormous explosion? Their first thought was that it was a meteorite, but they couldn't find a crater. They returned to their laboratory and carried out a series of slightly odd experiments. No one had seen anything like this before, and Tunguska became a scientific mystery. Since then, scientists have had many theories, but it's now assumed that an extraterrestrial object somehow exploded about 8 kilometers up in the atmosphere. This aerial burst was equivalent to about 20 million tons of TNT. Perhaps a similar aerial burst, but even bigger, happened in Egypt. What happened there was hot enough to melt the ground over thousands of square kilometers. This is where Boslow's expertise comes into the story. At the Sandia Labs in New Mexico, he's developing a computer model to see if the airburst theory can be right. An event in 1994 was the turning point, the impact of the comet Shoemaker-Levy with the planet Jupiter. When the comet went into orbit around Jupiter, it broke up into over 20 fragments. Then, one by one, these fragments hurtled down into the Jovian atmosphere. Nothing similar had ever been witnessed.
I think that the impact on Jupiter was really one of the most exciting things to ever happen in the history of science.
Boslow's speciality is the physics of large impacts, and for that he uses computer simulations. For Boslow, the Shoemaker-Levy comet was to be the biggest, most exciting experiment imaginable.
This was a real opportunity to see something that we couldn't see in the laboratory, something of a scale, of a magnitude way beyond anything imaginable, beyond our wildest dreams.
Boslow's team had been developing a new theory which predicted that the impact would produce a massive fireball.
This is a sequence of snapshots from our simulations. The top image shows this incandescent fireball rising over Jupiter's horizon to be seen from Earth. And in subsequent frames you see this fireball growing and cooling, but growing into this enormous plume to very high altitudes. It just gets huge.
When the fragments of Shoemaker-Levy smashed into Jupiter, the pictures from the Hubble telescope were just as spectacular as the simulation predicted.
When we saw the Hubble Space Telescope images for the first time, we were so excited to see this spectacular plume rising over the horizon.
Their predictions were very close.
These are actual observations, snapshots from the orbiting Hubble Space Telescope. In the first image, you see this incandescent fireball rising over the horizon, and in subsequent images, you see it growing into a plume, and it continues to grow to this enormous size.
This massive plume of hot gas they predicted was ejected well over 3,000 kilometers out into space.
It was a spectacular explosion. I mean, it was just a tremendously enormous explosion beyond anything anybody's ever experienced in the solar system.
The Shoemaker-Levy impact on Jupiter was a pivotal moment in science. It made scientists rethink what could happen here on Earth.
So this really was a turning point in my understanding about how impacts work. I and most people thought of impacts on Earth as events that create craters, collisions with the solid Earth, and typically we ignore the atmosphere. We ignore atmospheric effects. Well, the atmosphere is tremendously important, and this is the lesson we learned from this.
The Shoemaker-Levy explosion had been observed with interest by another scientist too, John Wasson, one of the world's top meteorite experts. He had also been puzzling about the origin of Egyptian desert glass, looking in particular at one special piece of the glass.
It's special because it has very distinct layers. The layers consist of dense glass, which is almost free of bubbles, and foamy glass, which is full of tiny little bubbles.
Wasson believes the layers were formed by intense heat radiating from above, from an extremely hot sky, and he remembered the explosion over Tunguska.
When the thought came to me that it required a hot sky, I thought immediately of the Tunguska event. That's exactly the kind of event that I need. An aerial burst, but many, many times larger than Tunguska. Perhaps 1,000 times or even more times larger.
And the massive fireball produced on Jupiter by the comet Shoemaker-Levy seemed to offer a possible explanation.
I thought, how nice. The Shoemaker-Levy comet seemed to me to be ideal for producing an aerial burst and producing desert glass.
It set both Wasson and Boslow thinking, could a similar aerial burst happen here on Earth? To take this idea further, Boslow needed to adapt his computer model to simulate an aerial explosion, and for that, he needed more data. He wanted to see for himself how widely the glass was spread in the desert.
I think it's helped a lot to see the distribution of the glass, how widespread it is in some places, how concentrated it is in others.